So welcome everybody to this webinar titled Triple Rinse versus PerfluorAd. We're going to talk about basically how you clean out firefighting systems to become PFAS free. And the two panelists you see here, we have Cheyenne Simontob and Greg Knight, and they will be introduced a little bit later as well. But I just want to quickly tell you, throughout the webinar, which will be about 30 minutes of talking, followed by about 15 minutes of Q&A if you guys type in questions. There is a tab down below that's called Q&A. That's where you put it. It's not raise your hand or any of the other locations. Type in your questions there anytime, and we will try to address them towards the end of the webinar. This webinar is also recorded and will be made available via YouTube later on. If you feel like you have to watch it one more time, or you know someone who should also watch it, so please don't hesitate to share that. I'm going to spend just a minute or two to introduce the topic. Essentially, what we're talking about is our ability to put out fuel fires, and water is typically not enough. The AFFF or aqueous film forming foams were developed to basically allow us to put out fires much more efficiently on hangars and ships and anywhere there's a fuel fire. In order to do that, we have also these trucks. As an example, I'll show a truck here, an AFFF truck as they're called, so an airport rescue firefighting truck. These vehicles, along with domestic firefighting vehicles, can have foam tanks so that they take on water, or they have water on board. They mix the AFFF concentrate with water in as they spray, and all of a sudden they can put out fuel fires that otherwise would be very difficult to put out. So this AFFF has a lot of PFAS in it. That's one of the reasons it's so so strong against heat and doesn't get degraded. However, the PFAS, of course, is an environmental concern, and now we have to transition from these AFFF foams to fluorine-free foams. And in doing that, you got to get as much of the PFAS out of the inside of these trucks as you possibly can. So you drain the concentrate tanks, and you see real AFFF here draining out of basically a foam trailer at a site we worked on. That's the first step. Get the concentrated AFFF out of here. They could be anywhere from 30-40 gallons to 500 gallons on big airport firefighting trucks. And then the second thing is, after you do that, rinse out the tanks and also the internals of the fire trucks so that as little PFAS as possible is left behind. That's what we're going to talk about today. Is it enough just to do it with water, cold water? Or do we need to use basically cleaning agents such as PerfluorAd to be much more efficient at it? So in other words, do we set up like this and just run water through the systems and then create a few thousand gallons of water waste for every truck, get rid of that? Or do we need a more thorough rinsing using a warm solution like we have in this silver tank on the right to actually get the PFAS, more of the PFAS out? What's the difference in cost, in time, and in efficiency of these? It's very important to us in the industry because it's not just a few trucks. We have the whole country, and a lot of the rest of the world is basically scattered with these vehicles. And you can imagine that each one of these will contain many pounds of PFAS, and the scale of PFAS regulations, that's a whole lot of mass. So how clean we make these, because we know they're going to go out in service and they're going to spray, is very important for how much PFAS we continue to expose ourselves to. So with that, I'm going to open it up here, if I can make it work on the webinar. Sorry. I was trying to do stop share. Here we go. So now it's time to introduce the two experts on the webinar. Greg Knight is TRS's expert in PerfluorAd and AFFF Cleanout. And I will let Cheyenne, I will please ask you to introduce yourself so we can get that right.
Thanks, Gorm. I'm Cheyenne Simontov. I'm a principal at EFI Global. We're a national environmental engineering and fire investigation firm. We've been providing these services for a little over 50 years. And it's been a pleasure working with TRS on a project here that we're going to be discussing today. So I think we want to talk about an example project of a recent AFFF cleanout that we performed at a major international airport recently. We had an opportunity to team with TRS on this project, provide this service to the airport, and really felt that it was a good pilot and example of some of the options between just a triple rinse and performing an enhanced clean out of a fire truck. And so, maybe we can just kind of get right into it. Gorm and Greg, AFFF, it obviously contains a lot of PFAS. What are some of those characteristics, Gorm, that, why is PFAS so prevalent in AFFF, and why does it make it so difficult to remove at these low concentrations?
Yeah, well, I can start share my screen real quick one more time. Just to introduce PFAS, these long molecules with tails and heads, right? There's all kinds of different ones, more than 5,000 different ones. Why they are so difficult to deal with is because they can form these films, they can form layers that look a little bit like crystals. When it weathers, they can mix with rust inside the inside of pipes and so on. And you get these crusts formed inside the vehicle. There's a very, very intriguing paper by John C. Lang and others from Arcadis, just recently published. I recommend everybody read this, where they basically studied this, and they did all kinds of things, chemical extracts, and also something similar to what we're talking about today, comparing soaking these things in water with soaking them in fluorofighter, which is their agent for doing this, and in methanol. And it took a lot of pictures also of the inside of pipes and found these very rough surfaces. Pipes start out pretty smooth, and then they get these crusts and surfaces. So it's not just that yellow honey-like material that you can just flush out of there. It's also, over time, these hard crusts and surfaces that form on the inside of the fire truck that make it so difficult to get them released.
Yeah. And as a generalist, my first thought is let's just flush it with water, right? Seems like the baseline way that you can approach cleaning out a truck. But I suspect that there's, I think something we should discuss is some of the limitations there, right? You start with a triple rinse. Let's talk a little bit about that, as a baseline approach and what that accomplishes and what it might leave behind. And then from there, what kind of enhancements you can go into.
Yeah, so the triple rinse has been kind of the standard in the industry to start this process, but we're finding out that that's not enough. It's AFFF, it's film forming foam, so its job is to avoid water. PFAS was created as a nonstick, stain repellent, so it's going to repel moisture. So water by itself doesn't quite do it, and we found too as well the AFFF concentrate, when it gets exposed to air, it can start to crust up, and it gets stuck in the nooks and crannies, on float switches, in the corners of tanks. It really hangs on. It hangs on tight. So you need a little bit more proactive cleaning to get more of that PFAS out. Water alone isn't quite cutting it.
And I think when we're talking about triple rinse, it's almost literally just 3 volumes of the system, cycle it through, do the best that you can to just kind of rinse it out, right?
Yeah, I mean, to simplify, yes, triple rinse is basically 3 flushes, but there are variations of triple rinse. I'm not gonna get too much into it. Sometimes it's just the volume of the foam tank, fill it, drain it, fill it, drain it, fill it, drain it. Other times it's, cycle through the truck and try to get some of the action of the truck mechanics working to flush more out. And then sometimes it helps to actually agitate it and drive the truck around the parking lot for a while, try to agitate that, get that water sloshing around. And there's other variations. There's so many. We could probably spend 30 minutes talking about each variation. If you want an interesting read, I think the Australian government put out a document about how they would do a triple rinse, and it's a lot more intensive. And I don't know the results, but time to do that specific rinse was pretty lengthy.
Yeah.
And as we know, we'll probably get into later, you can't take these trucks out of service for 2 weeks. There's a lot of other factors involved. So, time is of the essence.
Yeah, I think one thing that was interesting to me and I think was important, and getting into an enhanced cleaning system also is you're going to probably use a potable water supply to help with the triple rinse, right?
Right.
And I think one thing that there's possibly going to be some low levels of PFAS even just in the potable water and the makeup water supply that you're using. So, it's something to consider, is even just that water that you're adding is probably going to have some low level PFAS just from a municipal system that you're drawing from.
Yeah, our standard procedure is to take a sample of that potable water supply before we start. And like you said, it's usually low levels, and there's some, we've come across it, I would say, I don't know, 60% of the time, we come across low levels, and those will change over time. If you've got a stagnant line that you're using water from, there could be a buildup, and then as you flush it out a little bit, it goes away. But it's good to know, especially when you're comparing starting points and final points of your clean out, what was influenced by outside sources.
Yeah. And I think as we talk about these different processes, I think the sampling that goes along with it is an important aspect also. You're talking about parts per trillion, significant concentration reduction, and having control samples along the way, and checking it after a triple rinse and a enhanced PerfluorAd rinse. I think it's definitely something that's valuable as you go through these processes and track your actual results. And I know it's something that we're going to get into in a little bit. Kind of moving on to the PerfluorAd process, I think the triple rinse just being a basic kind of clean out, insufficient in many ways because of the characteristics of the AFFF. What is that PerfluorAd process like? I had firsthand experience with it. Quite a complex system that performs well, and let's go over some of the fundamentals of the system, how it works, and what some of those results could be.
Yeah, I'll kind of start with explain what PerfluorAd is for those who may not be familiar with the product. So PerfluorAd is a liquid product. It was developed by Cornelsen in Germany, and TRS is the exclusive licensee in North America of the PerfluorAd. So it's a liquid ingredient. It basically, you add it to, and it can be done for fire truck cleanouts, but you can also do it for wastewater treatment. So basically, you add some of the liquid PerfluorAd to your PFAS impacted water, and it creates an anionic bond with the PFAS, and then starts to create a flock. So you've got the PerfluorAd added, you have a mixing component, and there's a retention time for all of this to work. It creates a flock. And then once you've got that retention time met, you can transfer this water into a settling period or another tank. And we'll talk a little bit more about the process. And that PFAS settles out and becomes a manageable, visible product. And in this case, for fire truck cleanouts, we have kind of a sludge, and that can be pumped out and decanted from the rinse site. So the amount of PFAS that actually gets removed relative to the amount of rinse site generated is a very small amount. That video there kind of shows the flock forming. This is in a bench application. So the perfluoride is basically added into a solution. We create a solution of perfluoride for cleaning out a fire truck. We'll create a perfluoride solution in a heated water mixture. We'll try to get it to 50 to 60 degrees Celsius. Think of it kind of like if you're trying to wash a cookie sheet, you've cooked some bacon, cold water is going to have a hard time getting that grease off, that residual grease. Using hot water, you'll have better results. So we kind of use that same process. We heat up the water, we add our perfluoride, we mix it, we create a solution, and then we recirculate it through the truck, through the foam tank. And so we have that contact time for perfluoride. It's agitated, it's cycling through either via pumps or through the power takeoff of the fire truck itself, and using the hosing and the venturis of the tank, the fire truck itself, to recirculate that perfluoride solution throughout the truck. And once that's done, and typically what we'll do about 90 minutes, we'll do a recirculation loop. And once that's done, we'll send that off into a settling tank and let that perfluoride settle out. And then we'll follow that with a potable water rinse. Same process that we use for the perfluoride solution mix. We'll just do the same thing with potable water, run it through the truck, send it to the solution, and then mix it all together, and then let it settle out.
Yeah, it's quite a system. I want to kind of get into the specific project that we completed here recently at the international airport. So we had an opportunity to work on a fire truck and perform this perfluoride change out. Maybe we could share a couple of photos of that process, and really kind of get into the nuts and bolts of how we implemented this on a fire truck at the facility, and kind of recap that process as an application here on this specific airport.
Yeah, so we had a unique opportunity at this project. What we opted to do with client's approval, of course, was we wanted to do a triple rinse to compare that data. There's been some data released about triple rinses, but not a lot. So we wanted to do a triple rinse first to see what the results of that were, and then follow it with the perfluoride process and do that. So we can kind of do an apples to apples comparison. It's like, oh yeah, someone did a triple rinse on this truck, and we did perfluoride on a whole different type of truck. It's apples and oranges. So now we could do an apples to apples comparison. And then we also did a rebound test at the end. It was kind of a rapid rebound test. So we had kind of a unique opportunity to experiment a little bit. And I think the results were just fascinating and enlightening to us all. So this is good.
Yeah. Kind of getting into, go ahead, Gordon.
Oh, yeah. I just stole the screen for a little bit just to show an example of the control side of a fire truck, right? You go in and you analyze where water has been circulated, where foam goes in and out of the valves, and you write your kind of flushing recipe based on consultation with the firefighters who used to use these vehicles. And Greg, I don't know if you want to explain a little more about the actual process you did here with the next ones.
Yeah, usually the first thing we want to do is we want to talk to an operator to better understand the truck. In the short time we've been doing these, we found out that no two trucks are alike, even though they may be the same models. They have very different features and options, and even labeling is different from truck to truck. And as they're ordered, they're specified differently. So we like to sit down with the operator and have them walk us through the truck and find out which parts of the truck spray foam, which ones spray water, where are all the drains, how everything works. And we prefer to have an operator with us throughout the whole process. And sometimes that's not possible. As long as we get good training, we can kind of do all of that. But it's a very complicated process. These fire trucks aren't as simple as you look. You saw that first photo, how many controls there were. And not knowing, if you've not been trained, you may be doing some damage to the vehicle. So it's important to understand how this works and what works when and where and how. So that's a big part. That's the first step. It's a visual understanding, some training and discussion, either with an operator or even the mechanic of the vehicle is invaluable. So then we start to process, okay, how much capacity do we have in our tank? Our mixing tank that we use for these systems is 1,000-gallon capacity. How big is the foam tank? And then you can see that stainless steel tank there. That's our mixing tank. That's where we create the perfluoride solution. And you can see the black hose on the ground there. That's the draft hose. And that pulls from the bottom of the tank and gets pulled into the truck through the PTO. So it's got the draft to pull in the solution through the truck. And we use that to push the perfluoride solution through all the foam discharge points, through the turrets, cannons, and everybody calls it different things, deluge cannons, whatever you want to call them. And you see on the front of that tank, you see those little hooks coming over the side, and that's where the effluent of the truck goes back into the tank and creates that recirculation loop.
What do we need all the power for, all these cables? What's that for?
So the power we use, we can use either if you have a 240 service, or we can bring in a generator. For this project, we use a generator, and you can see on that panel all those plugs are. Those are our motor starters to operate. We have mixers, we have pumps, and then some other, and heaters. So there's this, every plug, every motor starter is dedicated to a specific component, and it's all self-controlled there. It's all manual, it's not very automated. So there's a little bit of running around and keeping an eye on levels and pumps on and off. And we do have a couple remote switches that helps with activating, deactivating pumps. So that's how it recirculates from the truck back to the tank. And like I said previously, once we've done that perfluoride solution, we'll let it run for about 90 minutes. We'll turn it off. We'll manually pump from this tank to another tank, and then we'll fill this tank with potable water, turn on the heaters. They don't get as hot as we do with the perfluoride solution, and then run a perfluoride or a water flush the same way we did the perfluoride flush. And that we count that as one flush. We do a perfluoride followed by potable water rinse, and then that's a flush. So we'll do anywhere from 3 to 5 flushes on a truck to get it clean. Again, it's part of it. Since I think we go back up a little bit, there's no PFAS analytical that you can run in the field. You can't do real-time analysis. You have to take a sample, send it to the lab. They're going to need a few weeks to run it and get it back to the results. So we don't have time. So that first flush we see a lot of foam. We see a lot of debris, a lot of rust. Things have been just stuck in corners in the truck for who knows how long. Finally breaks free and comes into the solution. That first flush is usually pretty dirty. And then we start to see it get cleaner and cleaner as time goes on. So that's a big part of it. It's a visual process to see it, because you can't see PFAS. And unfortunately, there's no other way to get through it. Oh, here's a photo. So you can see in this tank, it's got that rust color to it. You can see a little bit of foam up in the upper right-hand side corner of the truck, the tank. That's the foam. It's discolored. When we start out with the solution, it's kind of a milky white, light gray in color. But as we go through the truck and we start to loosen up debris and the foam, it starts to foam up a little bit. We will create what this comes looking like. This is typical first flush, looks like this.
Mm-hmm.
By the time we're done, where you started and where you end, you can't tell. So usually third, fourth, or fifth flush, it looks just like you started, and that's usually the good sign that you've probably cleaned about as good as it's going to get.
Yeah, I remember I was the one taking this photo. I was standing on top of the truck, and we had already done a water rinse, right, similar to a triple rinse. And I thought, okay, now comes the soap, the PerfluorAd, and the heat. And I wonder how much it was going to release. But all of this material that came out within 10 minutes was left behind after the water rinse, right? It was all in there, and it was loaded in PFAS. So that at least to me was a strong visual as of how much more we're actually going to get out when we do it this way. It's like doing your dishes with cold water in the sink, and when you do the rinsing, it gets a whole lot cleaner once you got the heat, the soap, and the mixing, which is the equivalent of what we do here.
Yeah, the mixing component is critical to keep that flock formed.
Yeah, I want to circle back on a couple of things that you mentioned, Greg. I definitely think having an operator that's familiar with the equipment and the history of the equipment is very beneficial, not just in the safe operation of it, but I think what we found as well is there's different nozzles on these trucks. There's different pumps. Some of them have discharged before and some of them haven't discharged before. And having an understanding of what that truck's done in the past, you really want to hone in on your clean outs and the appropriate parts, and not necessarily or inadvertently try to clean out or introduce low-level PFAS rinsate into portions of the truck that have never been exposed to it to begin with. So
yeah, that's critical. I'll use an example. We did a recent clean out, and we found out the check valve that was between the potable water tank and the foam tank of this truck. This was an older truck. It was about, gosh, it's probably almost 40 years old. The check valve doesn't work. So whenever they would fight a fire with this truck, it would get foam in the water side. So, instead of normally we don't go after the water side,
Right.
Usually pretty separate. In this case, we had to do a clean out of both the water side and the foam side. So it took a little bit more planning and thinking, and we had to modify a little bit of our procedures because of that check valve being failed. Trying to fill the foam tank would fill the water tank as well. So we had to be, add an extra pump to help keep the levels in check. But those are the kind of things that happen. And if we, the operator is key to telling us what that truck's seen or hasn't seen. Like I said, we don't want to introduce low-level PFAS into a cannon that has never seen foam before. So
yeah, the other thing also I think is that the internals for these trucks are rated at certain temperatures, right? And we're heating that agent and sending it through and making sure that we keep it at a compatible temperature with the internal components.
Yeah, we let the client know ahead of time, our target temperature, and if we need to go lower, we've got control of the heat that we can definitely go a little bit lower. But we've got a bandwidth that a sweet spot for the PerfluorAd. So we have some wiggle room. I think most of the materials in trucks are pretty safe to high temperatures. Gaskets, that becomes the question. What did the manufacturer use in a gasket? And that's where we ask the client to make sure, check back with the manufacturer, check the specs they got the original manual. So
yeah.
Knowledge is power.
Let's talk logistics a little bit about how you actually implement one of these space-wise and the amount of room and the number of days that you might need. Gorm, I think you had a couple of real good pictures showing a couple of different bays and the setup. I want to talk a little bit about how much space you need logistically, what kind of a commitment you need from the firehouse to actually implement one of these. What's been your experience, Greg, on getting enough space to perform one of these cleanouts?
Yeah, so typically our batch system is what we call this unit that we use for cleaning out fire trucks. Takes about, it's about 360 to 480 square feet that we need to set these up. Depending on the length of the fire truck and the size of the bay will determine, where we can set up. And ideally, we would like to have it like this, where we have one bay for our system and the adjoining bay for the truck. Sometimes we don't have as much room. We don't have the luxury. We got to cram things in a little tighter. But this is the ideal scenario. So yeah, we can get pretty compact. Our entire batch system fits on a standard semi-trailer bed. So it's one semi-truck to bring it to the site. We need a day, maybe a day and a half to set it up. And we usually like to set aside 5 business days to clean the truck. And that's a max. We could probably do it in 4, depending on timing. And, if there's no restrictions to how many hours we can be on site. So the goal is to have that truck in and out in 5 days. And then we need a couple of days on the back end to, decontaminate and clean up. Yeah. But the truck can be released at that point.
I can just add to it a little bit. You see the yellow fire truck here in the background, right? Here's the 1,000-gallon mixing tank. That's the circulation tank with the hot PerfluorAd solution. And then there's a couple of totes. These are 260-gallon totes, right? And then this is some filtration and carbon to polish the water. And to the right here is our flocculation tank, where we basically process. Let's say we use 2,000 gallons of water to clean this vehicle. We actually reduce the amount of waste by flocculating the PFAS out of the water and then running that water through carbon. So the water is treated and can go to a sewer, and we just generate a few gallons of waste, which is the perfluorad flocculant. And then at the end of all the fire trucks, right, some spent carbon. So one of the main things here is if we were doing triple rinse and didn't have all this perfluorad and these tricks, we'd probably be generating a few thousand gallons of PFAS laden waste for each fire truck. And instead now we're processing it and we're generating something like on the order of a drum instead.
Yeah. I think that's an important, that's the second part of this whole process, right? One is getting that fire truck, as clean as possible, the clean out as effective as possible. But now you've got a couple thousand gallons of rinsate that you've got to deal with, and it's PFAS laden. And what do you do with that? So maybe we can expand a little bit on the water treatment on site and what that process looks like. I know, Gorm, you kind of went over it really high level, and kind of the secondary objective is to minimize the amount of offsite disposal for this rinsate.
Yeah, so after we do the flushing, we have, and I said we put this in a settling tank. So that settling tank, we add a little bit more perfluorad, mix it up for 30 minutes, and then we let it settle. It takes a while for the flock to settle. It takes anywhere from 2 to 3 hours. And once that flock settles, we pump it out through the bottom until we get clear water. And then we'll pump that rinsate, we'll pump it through a bag filter and then through liquid phase carbon to polish it. And then in this project, we sent it to a frac tank. So all our rinsate got sent to a frac tank. So we're right, we're cleaning the fire truck. We're settling the PFAS out with the perfluorad in a sludge, and then the rinsate gets a further polish with carbon, and then we store it. For this project, I think we had about 5,000 gallons. I can't remember the exact number. It's about 5,000 or 6,000 gallons, somewhere in there, of rinsate that we treated with perfluorad. And then once that sludge gets pumped, we pump it into a drum because it's not a large amount. We let that settle and we dewater that a little bit further. We send the water from the sludge drum back to the process in the settling tank and let it go through the process again. So the amount of sludge generated is a small amount. If water dewatered properly, the sludge, if we're doing 6,000 gallons of rinsate, you may have, a quart of solids to deal with. And this is what it looks like at the end. This is the sludge being condensed into one drum. So it's not quite solid, it's semi-solid. I shouldn't say solid. It's a solid, semi-solid. It's liquid, and the flock.
Yeah. One of the things we're looking at too is whether we can destroy this on site using the HALT process, hydrogen alkaline, or what do you call it, subcritical water oxidation, or supercritical water oxidation. So in the future, we'll be testing essentially that, so that we can have more or less no PFAS waste leaving the site as well.
So this is the concentrated PFAS in the sludge. This as of now, Gorm talked about destruction opportunities, but I don't know if we're there yet, but this has to be disposed of off-site.
Yep.
So the rinsate, the collected rinsate, at that point, we collected a sample for this project, and we were able to see that we got below the discharge criteria. So all that rinsate could be discharged to the on-site industrial wastewater treatment facility there.
In the interest of time, I know we've got some questions that are kind of piling up, but before we get into that, I want to kind of discuss the results of the triple rinse and the perfluorad process. Kind of the crux of it and the comparison. What do we see as a baseline with maybe just a triple rinse and then a post perfluorad process? Gorm, you want to kind of walk us through that a little bit?
I can do that, or Greg, you can do it. I'll take the first.
I'll walk you through it. I'm pretty familiar with it. So look, going left to right. So on the left side, we have the baseline. So basically, after we drain the AFFF concentrate, we fill the tank the first time with potable water. And this is a sample of that from the foam tank. So you're looking at, greater than 60,000 nanograms per liter of, this is total PFAS. What was interesting after we did the triple rinse, the bar in the center, that the total concentrations of PFAS went up. Can't see it here, but that, and you'll when you see the next graph, it'll kind of explain a little bit, but we saw that increase was really the 6.2 FTS is what we saw. So if you look at PFOA, there was no PFOS in this foam at all. And our criteria for this discharge was 2 parts per trillion for PFOA and PFOS. So looking at PFOA, we started with 1,290 nanograms per liter, and that's from that baseline, that first water rinse. After the triple rinse, we saw pretty good reductions. It's about an 86% reduction, and that's the triple rinse was 172. But after perfluorad, we were down below 1. That's 1 part per trillion. So that was clearly effective. You go back for a minute, or we look at total PFAS, and then you can look at the perfluoride. You can't even see the values here, but I can tell you that the total PFAS concentrations here, I mean, I think there was no PFOS, PFOA was under 1, and I think the biggest constituent remaining was the 6.2 FTS. So yeah, you can go back to the other one. Yeah. So pretty good reduction with water for PFOA, and we kind of know that water is effective with PFOA, but for PFOS, water is not effective. We couldn't see that here. There wasn't any in the foam to begin with, but from other reports, especially a NESD report, it was prepared by the Navy. They said, water is almost ineffective on PFOS. I think there's one more graph too. So yeah, so looking at comparing total PFAS reductions with triple rinse, we kind of saw negative reductions because of that increase in the 6.2 FTS. But then after the perfluoride process, the one in the center, this is just the fire truck, 99% reduction of total PFAS. And then the rinsate, all that water we treated again and ran through carbon and stored in that frac tank. We're all 99.9% reduction. Doesn't show it here, but there was basically non-detect for all PFAS except one. Let me guess which one that was. There was 11 parts per trillion of 6.2 FTS was all that was remaining in that rinsate. Again, the discharge criteria was just for PFOA and PFOS, basically non-detect. So all that rinsate we generated can be discharged.
Yeah, potentially. Yeah.
Yeah.
Greg, I have some questions that are coming in that are associated with the graphs that you were showing. If you don't mind, perhaps we can answer a few of these questions.
Sure.
What methods did you and the team, and perhaps, Greg, this is also a question for Cheyenne, but what methods did you use on this project to measure both the individual and total PFAS data that's being shown here?
I do believe we use 1633.
Yep.
Yeah. And that's the new method, the newest EPA approved method.
And Greg, you made reference to the rebound testing that was performed at this particular application. Would you mind elaborating? We've got some questions that are coming in. Someone is interested in learning, is this a rebound test that was completed over a year, a month? Please elaborate on the duration and perhaps what's in the future with other rebound tests that are planned for other projects.
Yeah, so we did what we call the rapid rebound test. And I think, like I said earlier, there's like multiple iterations of a triple rinse. You could do the same with a rebound test. So what we did after we finished the clean out, we let the truck sit empty for 72 hours. And then we came back with a clean tank, brand new unused tank, brand new hose, and two brand new pumps. We created a recirculation loop through that AFFF tank. We ran that water and created a recirculation loop. I think we ran about 3 hours. Collected a sample before we started. We actually collected makeup water sample alone. We did the recirculation loop minus the foam tank. We sampled that, and then we sampled with the foam tank to get a kind of a broad understanding of what the rebound was. And we did see a rebound. Again, 6.2 FTS was the big one. I don't have those results handy, but again, this was just kind of a rapid rebound test. Time was limited. We couldn't have the truck for a month. I know there's been discussion in some of our colleagues, and we've talked about, can we put fluorine-free foam in the tank and come back and sample it periodically? And that would give you the most realistic data. But I don't know the plans for this vehicle after we were done with it. I don't know if they put fluorine-free foam in it or it's still empty. I have no idea. But I think there's still a lot of research that needs to be done on rebound. I think because we know PFAS is persistent and it's difficult to remove, I think we're going to see, rebound in any type of material, be it steel, plastic. I don't think it matters. I think we're going to be able to see rebound, but I think that the key is can we minimize the amount of rebound we see? And by doing a good job cleaning it in advance, I think we kind of resolve that.
Yeah.
I think a very important difference between the rebound or the leftover we saw when we did the cold water rinse, right? You would still be able to find with a camera, we scoped the inside of these vehicles, you could still see the orange residue. You could see some of the AFFF concentrate that had just not been flushed out with the cold water. Whereas after the PerfluorAd, when you inspected the tanks with cameras, all of that was gone. And what you would expect in terms of rebound is back diffusion out of the sidewalls of the tank and out of the gaskets and even out of the pipes. So I would suggest that the mass of PFAS that could rebound after triple rinse is orders of magnitude higher than what can rebound after a thorough warm PerfluorAd or fluorified rinse done properly, where you've gotten rid of all that honey-like material.
Yeah, because you look at it inside of a foam tank and it looks like it's shiny and smooth, but if you look at it at the microscopic level, it's porous as anything else. So yeah, that PFAS finding its way into everything.
Yeah,
there are a lot of folks on here that are suggesting we evaluate the use of swab sampling in our process and are asking, more or less for a state of the union, are swab samples available yet? Because how applicable would they be here? Big exclamation points.
Like I said, every fire truck is different. Some fire trucks, you can access that foam tank easily. Other trucks that we've cleaned, you've got a small 2-inch pipe coming out the top and that's your access. It's very hard to do what you would call an adequate swab. But yeah, there's been talk. We've had some of our partners we've done some R&D with have talked about swab samples. And I think it's valid to do those once we have, I guess the procedure to do that and adequately, because I always worry about, one person's way of doing one way, another person's not the same. Consistency is key. And as you can see, there's this photo here. That's all we have for this truck that this is not the project we did. This is a different project, but yeah, we created a recirculation loop where we're just recirculating PerfluorAd overnight inside the tank we built little diffusers because we had no access to that tank. It was very hard to get in there with a power washer or a jet or anything to try to get in those corners. So we had to kind of get creative. And then we had to do that with almost every truck. We had to come up with different apparatus or different methods to get those tanks clean as so that visibly there's no residual left.
And then, and then after Greg and Steve did all this, they would basically send a camera, like a scope camera down and look around the corners to see if there was anything missed before we completed the foam clean out. It's almost like a little surgery where you need the camera with you.
There are so many people on here that are asking about other applications. So I've got requests specific to fire suppression lines, non-vehicle types of applications. Would any of you care to comment about, potential applications for industrial settings that are not associated with the vehicles that have been shown?
You want me to jump on that one?
I can. Yeah. So so the same warm soap, if you will, would work for hangar systems, as an example. A lot of buildings at airports and aircraft facilities have essentially a couple of foam tanks and a mixing chamber and some pumps, and then they have all the sprinkler systems that run through the different buildings of the facilities, right? And some of them have been tested with foam. That means all the lines are contaminated with PFAS, and some of them have not, where it's just the mixing systems that have been tested. Either way, you can use the same type of cleaning mechanism and fluid and heat to decontaminate those systems. It's much easier to do it through the centralized systems, the foam tanks, the mixing chambers, and that, where there's also the highest concentration of PFAS. That you can do very similar to how we do the insides of a fire truck. If you have to do a whole factory facility with all these sprinkler heads and lines running through the different rooms, it becomes very, very difficult to manage. Luckily, most of those systems have tiny amount of PFAS in those pipes, and almost all the PFAS in the mixing rooms where the foam the foam concentrate was handled. But yes, the same soap and process can work in those places.
Yeah.
Another question came in, and this one is from Randy Cross, and I'm sure it comes as no surprise given previous conversations with Randy, but he is so anxious to learn about, the FAA and the decisions that are coming, especially next year. He is predicting high demand. He's nervous about it, and he would like to hear our thoughts on how fast scale up is actually doable from this team.
Gorm.
Yeah, that is a fantastic question, right? There's no doubt that there are a couple of different liquids now that are being tested and proven to be very effective for this, and the PerfluorAd solution is one of them. Arcadis has their own fluorifier that I mentioned in that paper. There's some other ones too. So we're not alone coming out with, here's a good soap for you, and here's a way we want to set up your system like a washing machine or dishwasher. But yeah, it's a major challenge. We have the recipe. We have guys who can train other operators how to do it. Getting it all coordinated where we get, let's say, 1 week per fire vehicle in a place where there's water and power and all that, and the fire vehicles can come in and out at a schedule. That's the major logistical challenge of scaling this up, right? And we know we need teaming partners. We know we need to find other folks and companies who are really good at that type of scheduling. We may even sometimes need loaner vehicles. Say at an airport, you have 10 of these ARF vehicles, and there's one for each of the major run or terminals. Maybe it's 5. They can't just take one out completely for a week, because that means they lose their license to land the big planes, right? So they need a loaner fire truck. There are all these logistical challenges that we definitely need help solving, and we'd love to team up with someone in the industry who can manage a lot of that. A small 65-person firm is probably not going to be able to do all that.
Yeah, we're starting to think about this. So, you mentioned logistics, and there are several questions about logistics. So I'll try to cover some quick ones. How many flushes are enough, for instance? What's the duration of the retention time for these flushes inside of the vehicle? What's the temperature of the water? We've referenced settling of the flocks several different times, but how long does it take to have the flocks settle out of solution? Are we using other means of settlement or separation, rather, I should say? Greg, would you add some answers to several of the questions?
Let me try to hit all of them real quick.
Okay.
So a typical PerfluorAd flush through a truck is, like I said, about 90 minutes. Sometimes we'll run it 3 hours. We'll do probably 2 flushes a day, maybe only one. But typically a clean out will be 5 business days, and that's on the outside. While we're doing perfluoride, after we get that first perfluoride flush and that water gets put in the sedimentation tank, we can get started on another flush. So the two aren't intermingled. It's kind of 2 separate processes, so that settling is going on while we're still doing flushing. But it's a continuous process, so we're doing all of that. And then the water temp, like I said, we have a bandwidth that we can be, but we want to be between 50 and 60 is ideal. We can go to 100 Fahrenheit. That's the low end of the scale. So I think I got them all. But yeah, it's 2 processes, but basically the actual flushing of the truck, 5 days. There's some setup before and some breakdown after. We need to occupy space while we do that. But the actual truck, we just need that for 5 days. And some trucks might need less. Like I said, it's a visual process. We did 1 truck at a project, over a year ago. I think we were done in 3. The results verified that. So
there's a lot of questions about the waste that have streamed in. So let's talk, conceptually, let's say 1 truck, what's the volume of the flock in the end that needs to be dealt with? And what's the volume of the water that has been cleaned? And what are we doing with that effluent water? How is that going off-site? Quick comments on that.
Yeah, so the amount of flock, is determined by the amount of PFAS, but typically you do 1 truck, and let's say, just for a rough number, 5,000 gallons of rinsate through the process. And that amount will vary depending how big your foam tank is and how much water we need to prepare for that solution. So you could get down to we're talking a small size of a quart of ice cream of PFAS sludge for 1 truck. And then you've got the rinsate. And I said, we add more perfluorad to that rinsate. We run it through a bag filter and run it through liquid phase carbon so we can get to a discharge criteria. If there's not a discharge option or a deep well injection option, then you're looking at some offsite disposal. But at that point, I don't know what that would cost. And then the other waste items you have is, we've got some carbon at the end. We use 2 200-pound vessels, so there's gonna be 400 pounds of carbon, some spent bag filters, and PPE, and just regular municipal trash, Visqueen or paper towels and whatnot, things like that.
Yeah, absolutely.
So there's not 0 waste yet. We're trying, but we're not there yet.
Not waste free, not yet at least. Considering the volume of questions that we've received, I'm really surprised that this group has not received more questions about costs. Only 1 or 2 of them have trickled in. So I'm not sure if cost is just not an option with this group, but
money is
Diane,
not
Greg, Form.
Yeah.
Let's talk through the cost breakdown. Perhaps, we can speak generally about perfluorAd and scaling up what that might look like, but also any type of comparison that could be offered from the triple rinse perspective as well. I'd love to hear your comments on that.
You want me to jump in? Okay, go ahead.
I can help you a little bit, Greg. So the systems you've seen here, GRS is 1 truck at a time system, right? Where there's a significant amount of mobilization. So it cost us about $30,000 to set up somewhere and tear down and ship it back to Indianapolis out. And so there's like a minimum demob fee of about $30,000. But then once you're out there, you can clean a vehicle per week for about the same amount of money. So, if you only have 1 truck, it's probably in the $60,000 to $80,000 range. But if you have a whole lot of them coming in, it's like half of that per vehicle. And remember, these are vehicles that sometimes cost, $1.4 million, some of them, if you needed to replace the vehicle, if you couldn't clean them properly. So they're being cleaned out and ready for fluorine-free foam for maybe a few % of the cost of a new vehicle.
Yeah, there's definitely savings. The more trucks you can do in 1 location, the lower we can get that price.
Yeah.
Yeah. Well, I've got some more questions that have trickled in from Randy. Randy, I love your questions. He'd like for Greg, you to provide a list of equipment necessary. He'd also like to start purchasing PerfluorAd independently. Randy is ready to go. He's got trucks that need to get cleaned out, and he does not want to have to wait in line. So we hear you, Randy. We are trying to build and scale things up accordingly. I know that we're getting very close to the top of the hour, so I'm going to leave you with probably the toughest question that I've seen come through, and that is, how clean is clean? Question. Can any of you answer this at this point in time?
Well, I'll give the short answer. It's better than doing nothing. Right, doing something is better than doing nothing, but I'll let Gorham speak to a little bit more semantics.
Yeah, so I'll share my screen again just to remind you of essentially what we achieved for this particular site, right? We got all that, the hundreds of gallons of concentrate out of there. That's easy enough. That dripped out. Then the baseline first rinse, we saw how much was in the water, 1,300 nanograms per liter. The triple rinse could reduce that by about 86%, and the PerfluorAd rinse could get us down below 1 nanogram per liter. We've done at least another 6 vehicles in Connecticut where we consistently were down in the same range between 0.1 and 2 nanograms per liter in the final rinse after PerfluorAd. So, if we restrict ourselves to 4 or 5 days of doing this, that's about what you get, somewhere in the 1 nanogram per liter range, or a reduction of, 3 to 4 orders of magnitude based on not doing it, or 200 times cleaner than if you did triple rinse. We're not the ones to say whether 1 nanogram per liter is clean enough, right? It's not drinking water standards. However, we did actually do it like some calculations of how much PFAS would be released before and after, and it's pretty striking that if we do a PerfluorAd rinse on every single vehicle in this country except one, all the ones that we rinse with PerfluorAd will release less PFAS that the single fire truck that we didn't clean out. So, and remember, they've been doing this for decades, right? They've been test spraying and all that, and they've actually drained their foam tanks. So if we treated all the vehicles now with PerfluorAd, there would be less PFAS released from all of them than one fire training event in the past.
Yeah.
So, don't know if that's clean enough, but it's a pretty good reduction.
It's cleaner. Well, Bill DiGiuseppe is online, and he is commenting about, he wants to remind everyone on this call the fact that fluorine-free foam is not void of all PFAS. It has been tested, and it has shown to have some concentration of PFAS. Yes, it is below a threshold, but it's going to be really tough, to assess rebound, especially later, once that fluorine-free foam is reintroduced inside of these cleaned vehicles, because the foam will come with PFAS, right? So, the low level detections that you're describing in a cleaned vehicle, Gorm, will unfortunately only have some level of PFAS added to it, even with the fluorine-free foam that's available to us today. So just keep that in mind.
We'll definitely also test, just like Greg has tested the fire hydrant water we've used for this to see if it had PFAS, and one of them actually did, and the line needed to be flushed before we did this. The same way, if we're testing new foams to go in, we will have to have a sample of that and make sure that the background PFAS level is what it is. We want to know what it is, so it's not misinterpreted as something that came off the sides of the tank, for instance.
Yeah. Absolutely.
I think what's also important to remember is what's the ultimate objective of this. And, it is important to get the internals of the truck as clean as possible to remove as much PFAS out of the internals of the truck. But ultimately, one of the primary objectives is that when that truck is deployed and when there is a fire and the AFFF is being discharged out into the environment, is to keep that level of PFAS that's being discharged into the environment minimal or as low as possible. And, you know, it also goes into the rebound testing and the swab testing approaches is, you know, is it most appropriate to try to do a water rinse and check rebound like that, or to swab the internals, or perhaps put the foam back in and take a sample of that foam over time, or that foam that's now mixed with water at the discharge point. So, you know, each one of these iterations of how the foam gets discharged into the environment, it's gonna to look at it in a different way on the actual concentrations that would be discharged into the environment, all said and done when that truck is put back into service.
Yeah, absolutely. Well, thank you all for your time today.
Yes, and I'll just repeat that this was recorded and will be made available on YouTube. And if any of you out there are not real happy with the answers we were able to give, by any means, shoot me an email, and we will talk about your questions again amongst us, and we will try to provide you a better answer than what we could here. Or if we skipped your question, just be stubborn, send it to me, and we'll get back to you. Thank you so much for listening, and see you next time.
Thank you.
Thank you.